Ms. Yashodha. In previous sessions, we will discuss about what is a data structure, and in data structure, we will discuss stack. Now, in this session, we will briefly discuss about what is a stack, what are the operations in the stack. In these stacks, we can use in DS. There are two types, that is linear data structure and another one is non-linear data structure. In this linear data structure, we can implement stacks, queues and linear search, linked list. In these stacks, we can use the data structure follow in LIFO manner, that is a last in first out principles. The stacks has one hand whereas the queue has two hands. That is stack has one hand and queue has two hands, that is front and right. It contains only one pointer, the top pointer pointing to the topmost elements on the stack. Whenever an element is added in the stack, it is added on the top of the stack and the elements can be deleted only from the stack. In other words, it can be defined as the container in which insertion and deletions can be done from one end, known as the top of the stack. Some examples of a stack is a pile of books, a stacks of dinner plates, a box of Pringles potato chips. These are the stacks examples. Now, some key points related to the stack is it is also called as a real world stacks. That is examples of piles of books. And these stacks we can use ADT. As you know, abstract data type is also a classes and objects which is behavior is defined as a set of values and set of its operations also. In this ADT, the operations are to perform not how these operations will be implemented, and it is not satisfy how the data will be organized in memory and implementing the operations. These are called abstract data types. It gives the implementation and independent view. The process of providing only essential and hiding the details is known as abstraction. So stack is as known as a abstract data type. Now these are the standard operations of an stack, that is push, pop, stack is empty, stack is full and display. Let's discuss about what is a push. Push operation is used to insert an element in a list and the operation is known as push. If the stack is full, then the overflow condition is occur. And now discuss about what is the pop. We can delete an element from the stack, the operation is known as pop. If the stack is empty means that is no elements can be existed in the stack. In this state, these are called underflow state. In this push, we can use overflow condition, and this pop we can use underflow condition. Now discuss about what is empty. Is empty method. It determines whether the stack is full or not, and full is determined whether the stack is empty or not. Now we will discuss about display statement. It prints all the elements available on the stack. Now we will discuss about what is the push operations. In this push operations, we already know inserting an elements of a stack. We check whether the stack is full or not. If we try to insert an element in a stack and the stack is full, then the overflow conditions is occur. When we initialize a stack, we set the values of top as -1 to check that the condition is the stack is empty or not. When the new element is pushed in a stack, first the value of the top get incremented, that is top is equal to top plus 1, and the elements will be placed in a new position, and the new position is also called as a top. The elements will be inserted until we reach the maximum size of the stack elements. Now discuss about the pop operation method. In this diagram, we can use some stack. In this stack, we can use empty stack and the stack is full. In this stack, we can use 40, 10, 20. We can insert an elements in 4, that is 10, 20, 30 and 40. Now the top position is 3, that is 40. We will delete an element in the pop operation. We can use 40. 40 is deleted and the top 2 position is occurred, and the top 30 pop 30 is deleted and the top position is 1, and pop 20 is deleted and the top position is 0. and the pop 10 is deleted and the top position is -1. So pop operation is performed in this like. Now we will discuss about what is the pop operations. These pop operations are used to perform check whether the stack is empty or not. If we try to delete an element from the stack, the under four conditions is occurred, as you know. If the stack is not empty, we first access the elements which is pointed to the top. Once the pop operation is performed, the top is decremented, that is top is equal to top minus 1. In this push operations, we will be incremented, that is top is equal to top plus 1. In this pop position, we can decrement the top is equal to top minus 1. Now this is the push operation. In previous sessions we will know pop operation and this push operation. In this push operation we can use stack is empty, that is top minus 1. We can push an element as 10, the top is equal to 0, and then we can push an element in 20, the top position is 1. We can push an element in 30, the top position is 2. We can push an element in 3, that is 40, that is top is 3. Then stack is full. So these are the operations performed in a stack. Now let's discuss about what is the representation of a stack using an array. As you know, the representation of stack is a fixed, that is maximum number of elements that must be known in the advance. In this stack there is no fixed size. The size of stack changed with the number of elements that is inserted or deleted. The top of the stack is the first element of an array. The stack items are placed from item 0 to top minus 1, that is defined in index. Here some logic is described, has defined max 50. So maximum number of elements we can give 50, and we can use struct element, that is stack. In this structure we can use integer data type, that is a top position, and item is equal to item of maximum size. Let's discuss about the array representation of a stack. In this memory we can use in this A, B, C, D, E. In this E or the top element we can push on elements on the array, and given below the representation of array is index number is 0, that is 0 to 4th position. Now adding an element on the stack, that is push operations we can perform. Adding an element in the stack is referred as a push operation. The push operations is involved in 2 steps, that is increment the values on the top, it can now refers to the next memory location, and add the elements of the position of incremented the top, that is referred as adding new element at the top of the stack. This is the logic of adding the element of the stack, that is begin if top is equal to n, then stack is full, then top is equal to top plus 1, so element was incremented. Now stack of top is equal to item, the item is displayed and n position is come. Now deletion of elements of a stack, that is pop operation. In this pop operation we can use top of the stack is called pop. The value of the variable top will be incremented 1 when another delete from the stack. The topmost elements of the stack is stored in another variable, then the top is decremented by 1. These are the algorithms that performed on the pop operation. In this pop operation we can use whether stack is empty or not, that is if top is equal to 0 is must and should, and the item is equal to stack of top is in there. And now we can given the logic, that is top is equal to top minus 1, that is pop on one element. And now end position. Let's discuss about what is the representation of stack using linked list. The problem is implemented in the stack using array, that is suffer basic limitations of an array, that is the size cannot be increased or decreased once it is declared. It can be represented efficiently using linked list. The problem can be solved by implementing the stack using linked list. In this type of linked list we can use sorting the elements. In this stack we can given by the pointer, the pointing to the first element of the list, that is beginning of the list. The stack elements ordered from top to bottom in the linked list from the left to right manner. In this linked list representation we can use some logic, that is struct variable, that is stack, and int data, and struct is equal to stack into link, that is next node address. Now we can see on the diagram a stack contains 4 elements. that is 15, 20, 10, 44. In these 4 elements we can use 1005, 1007, 1009, and last one is null pointer. In this top position, in this stack order, we can give 44, 10, 20, 50. In this 15 there is the top position, that is top position is 50. These are the stack containing 4 elements used in the linked list. Now adding a node to the stack, that is push operation. The push operation is performed in adding one and elements, that is pushing an element to the stack in the linked list, and performing the implementation differed from array implementations. In this push operation we can use void push variable, and struct node is equal to ptr, that is pointer, and struct node is memory allocation size of the struct node. If ptr is null, then print push the element or enter the value. These are the program. Now deleting the node from the stack, the pop operation is performed. In this deleting a node from the stack, it is referred from the pop operation. In order to pop element from the stack, we need the following the steps. That is check for the underflow or adjust the head point content accordingly. Now discuss about check for the underflow conditions. In this check flow under condition, we try to pop from an already empty stack. The stack will be empty if the head pointer of the list point to null. And now adjust the head pointer accordingly. The value stored in the head pointer must be deleted and the node must be freed. The node becomes the head node. This is the algorithm for pop operation from doing linked list. Now, what are the applications of this stack? In these applications, we can use arithmetic expressions, that is called operators and operands. Here, operands are variables and constants, and operators are like various operators, that is nothing but addition, subtractions, and multiplication. Here, some operators and procedures, and it is that is associativities. Unary operators, exponential operators, multiple and division, additions and subtractions, and or not XOR. Now these are the example. This is one example from adding the arithmetic expressions. A is equal to 5 into 3 plus 4 minus 2. We are given 5 3s are 15, 4 minus 2, 15 plus 4 is 19, 19 minus 2 is 17. Here the notations for arithmetic expressions. There are 3 arithmetic notations are there. First one is infix, second one is prefix, and third one is postfix. We will discuss about infix. The conventional way of writing an expression is called infix. That is operand, operator, operand. That is C minus B, A plus B, etc. In prefix, we can place the operator before the operands. That is operator, operand, and operands. That is, we are given A plus B. The A plus B can be converted into prefix operation, that is plus AB. These are called the Polish notation. Now postfix expression. The postfix notation places an operator after the operand. It is also known as the reverse Polish notations. That is 2 operands, operand, operand, and 1 operator. That is minus AB plus CD minus EF into. That's so on. Now, how to convert an infix expression into postfix expression? The algorithm is print the operands as they arrive. If the stack is empty, they contain the left parenthesis on the top. Push the incoming operator on the stack. If the incoming symbols is there, that is open parenthesis, push it on the stack. If the incoming symbol is pop, the stack is print outer the outstanding of the left parenthesis is found. Now, the next point is, if the incoming symbols has higher precedence, the top of the stack is push on it. If the incoming precedence has lower precedence, that the top of the stack pop and print the top of the stack, then the test incoming operator again is the new top of the stack. If the incoming operator have same precedent with the top of the stack, we can use associativity rules. If the associativity is from the left to right, then the top of the print the top of the stack, push the incoming operator. At the end of the expression, pop and print all the operators of the stack. Now following some logical. Now given A into open parenthesis, B into C plus D into E closing parenthesis plus F. Here we can give operators of stack postfix expressions. That is operators only. Operators on stack means only operators can be operators and symbols are given. In postfix expression, the operands and operators are given in the postfix manner. Now we will discuss about what is the convention of infix to postfix. So first we can this is the algorithm. We can reverse the infix expression given in the problem and scan the expression from the left to right. The operands arrow print them and the operator arrow of the stack is found to empty. Simply push the operator into the stack. If the incoming operator higher precedent is the top of the stack, incoming operator into the stack. If the incoming operator has the stack revealing top, the stack is pushed and the incoming operator into the stack. The operator can be the top of the stack is print of the top of the test in incoming operator. Again is the top of the stack, again and pop. The operator will start till it finds the operator from the lower precedence or same precedence. Whenever we reach the end of the expression, the pop and print all the operators from the top of the stack is closing parenthesis, that is push into the stack. If the top is a stack, the push of the operators on the stack and the end in the reverse in the operators. So these are the expressions that is perform infix to prefix expressions. This is the another example for doing infix to prefix example. Now discuss about what is the queue and what are the different types of queues. A queue can be defined as a ordered list which is enabled to insert elements to be performed at one end called rear and deleted operations to be performed under called front. In queue is a first in first out manner, that is FIFO manner. For example, waiting a line for a rail tickets or bus tickets or tokens. Examples. In this diagram we can discuss about NQ, that is means insertion, and DQ, that is deletion, the front and the rear. These are the one end operators. And what is the representation of a queue? These are the representation of a queue. We can insert values 1, 2, 3, 4. These are the insert front end and the rear end, and front pointer and rear pointer. There are two ends, and this queue representation, there are 4 different types of operations, that is NQ, DQ. Q is overflow, that is full. Q is underflow, that is empty. NQ means insert the element and DQ means delete the element, and overflow is when stack is completely full, and underflow is when stack is completely empty. And these are the types of queues, that is circular, DQ, priority queue. In this circular queue we can use it to suffer one limitation. The implementation of the rear pointer reaches the end and the insertion will be denied even if the room is available at the front. To overcome this limitation, we can implement the queue in a circular queue. And given the example for circular queue, that is the front point is the first position and the last position is rear point. Next we will discuss about DQ, that is double-ended queue. The double-ended queue is represented on insertion and deletion operations both performed in the end, and that means insert at both front and rear position can be deleted both fronts and rear positions. That is in this session. Now we will discuss about double-ended queue can be represented in 2 ways, that is input restricted double end and output restricted double end. In this input restricted double-ended, the operations is performed only at end and deletion operation is performed both at ends. And output restriction double-ended queue is deletion operation is performed only one end and insertion operation performed both an end. And next we will discuss about priority queue. It is the collection of elements where the elements can be stored according to their priority levels. The order in which the elements should be get added or removed directly. The elements will be higher priority proceeding before any element of lower priority. If the elements which is same priority, then the elements added from got the processed. Now what is the array representation of a queue? So here the array representation of a queue, that is hello, we can give 5 elements with the array and we given front position and rear position, that is 0 and 4. This is the algorithm for representing the array. Now algorithm to deleting an element from an array, that is front -1, and linked list representation of a queue is used to Linked list is each node of the queue that consists of two parts, that is data part and second one is linked part. Each element of the queue point to its immediate next level element in the memory. The linked representation of queue is shown in the diagram. The operations in the linked list is two basic operations, that is first one is insertion operation and second one is deletion operation. Now discuss about what is the linked list. Linked list is also, in previous sessions we will already discuss about what is a linear data structure and what is a linked list. So linked list is first divided into two types, that is data part and the link part. A link part is defined as the data from the another node address. And what are the uses of linked list is they are used to perform anywhere in the memory has linked together to make a list that achieve the optimization utilization of this space. In this space is limited, the memory size does not need to be declared in advance. The empty node cannot be present in the linked list. We can store the values of the primitive data type singly. Let's see linked list representation. In this linked list representation, we can use head session and data items, next section, data items, nodes, and last one is null. In this data type and next section is also called a one nodes. Let's see what is the memory representation of a linked list. That is, to maintain the linked list, there are two parallel arrays of the equal sizes array. One array, this is info and is used to the next array elements of the node, and this figure we can show a single linked list with 4 nodes, that is start node, that is end node, null, a single list with 4 nodes. Now types of linked list, there are 3 types of linked list, that is single linked list, double linked list and circular linked list. Single linked list is performed to the next node of the sequence, the last node represented null indicating, and single list representation is used to perform a linear data structure. The last node of the single list contain the null, the next node will be indicated on the end of 1, that is info and the next position. A linked list contains the list pointer variable that is starts to store the address of the first node. Here show the some example of a single linked list. Now we will discuss about double linked list. Every node has two parts, that is one pointer to the next node and other of the point to the previous node. In this double linked list we can use previous node address and the next node address. The next pointer of the last node is previous pointer from the next node, and these are the previous, data and next. The structure of the node is display. Now we will discuss about what is the circular linked list. In this circular linked list we can accept the last node of the point first node, making it the circular list as shown, that is circular. Now in this circular linked list we have two types, that is singly circular list and double linked circle list. In this singly linked circle list, the last node point to the first node and there is only link between the nodes of the linked list, only one node, second node, third node. And the double linked list, the last node of the point in the first node and there is the two links between the nodes on the linked list. The linked list operations are creations, insertion or deletions, traversing and searching. Creation means it is create a linked list operation, and insertion means beginning at or ending. Next, beginning a deletion and ending deletion, and traversing means forward or backward. Searching means finding the elements in the linked list. Now we will discuss about traversing linked list. It is mostly commonly used to operation to perform the almost every scenario of the single linked list. That means each node of the list once is ordered to perform the some operations of this. Here some logic, ptr is equal to head. When pointer is not equal to null, then ptr can go to next position. The searching linked list or traversing linked list is can be divided shown in the figure. In searching, perform in the order, find the location of the particular element in the list. The elements list need to traversing through the list of the make every element list with the specified element. These are the some examples of linked list. Now we will discuss about deletion of the node in the linked list. We can delete a node in the linked list in various places, that is beginning position and middle position and end position. For the deletion position we can use step 1 and step 2. From the deletion we can use the algorithm, that is steps. Next, deletion at the beginning we can use in this diagram. So we can use Head session 9, 12, 19, 23. So we can delete at beginning. The 9 node should be removed. That is node B and node C and so on.